Hey, this is Mr. Marson, ready for phase 2 of completing your graphs. So far, the only thing we have done is in our template, we have our water usage in gallons, and we converted it to cubic kilometers. Then we're going to use a second tab on template. And if you notice up here, it says make sure all are in the same units. That's really important. So this is our template, which look like this, and we're also going to use our data. You get the data two different ways. One is from Emoto here, it's a spreadsheet, or you can also use website, the water and population data there. I'm just going to choose to use the spreadsheet. So we open it up, it looks like this. We want to know about the water, so we're going to click the water tab. So going back to my template and my data. So these are the two documents that we really need. The template that we worked on before, and the data which hopefully you just opened up. So the first column is total annual renewable fresh water, which doesn't really change too much from year to year. So we're going to look under the water column in this first header, water resources total renewable. This is what we need in the United States. So I'm going to scroll down to the United States, which is down here, and it is 3,069 cubic kilometers of water. So I'm going to go to my template and write that in, 3069. So the total renewable fresh water is 3,069 cubic kilometers. So if you take this cell, it's going to be the same all the way through. If you look at the data, again, 3,069, all these countries pretty much stay the same. So we're going to take that and just drag it down. So here you can see how it's a plus and it's hollow. Here it's filled in, so we're going to drag it down. So that takes care of that column. And here it's our water demand. Remember, it's a country full of us. So if we look back at our water usage, it was this number. So I'm going to take this number and copy it and paste it in this cell. And you can see right here how it says 0 because it's rounded, but up here you see the actual number I have. Now Excel's got a feature in it where if you type in 2 plus 2, it would just stay 2 plus 2. But if you make a formula out of it and put before the 2 plus 2 an equal sign, then it turns into 4 the answer. So we're going to utilize that feature up here. So remember, to figure out what our projection is of how much water we're going to use, we're going to make it a formula. So it's going to be how much water we use times the population of the given country. So in the USA, we have to go back and figure out the population. Here, the population for 1975 for the United States of America is 219,108. So I'm going to take that and times it by 219,108. And then I'm also going to times it by 1,000. And the reason I times it by 1,000 is, looking at this, all the populations are given in thousands. So in the United States, there wasn't 219,000, it was 219,000 thousands. So now, looking at this, we would end up using 70 cubic kilometers of water if everyone in the United States lived like I did. If you'll notice, there's a low, medium, and a high projection. Since it's a pest, those projections are just going to be the same. So it's going to be 70 going across. Now, looking at this, we can even take this and drag the 70 down because you can see up here in the formula bar that the formula stays the same. So the only difference between 1975 and 2005 is the amount of people. So I'm going to look back at my data. Instead of it being 219,108, it's 296,820. So I'm just going to go back and change that to 296,820. Now it's using 95, and this is going to be the same all the way across. So I'm going to drag it across. So now we have 1975 and 2005 done. 2010, I'm going to do the same thing, drag the formula down, and the only thing I have to change is the population, which is that middle number. So looking back at my data, I'm going to look and see what the population was. So now it went up in 2010 to 310,384. I'm just going to cut this number out and put in that 310,384. So 310,384. Again, this is the pest, so I can just copy this across. So far I got 1975, 2005, 2010 done by simply putting in the water usage times the population of that time period times 1,000 to get how much water I would actually be using. 2025 is going to be slightly different. Again, I'm going to drag it down and use that base formula, take out the population, 310, and I have to go to my data and see in 2025, now it's the future, So in 2025 in the United States, the low population is 337,475. So I'm going to put that number in there. 337,475, and hit enter. So it's 108. But when I drag the formula over, I can't drag it all the way over because that was my low projection. Now I have to look at my data and put in the middle projection in 2025, which is 349,758. So I just have to change that 337 to 349,758 to get my new population there. And again, I'm just going to drag this cell over, and I'm just going to change the population in the middle. So the high projection for 2025 is 362,041. So I'm going to take out that middle one and put 362,041. You can see how it's steadily increasing the demand of water as the population increases. Okay, just one more time, it's getting repetitive, but just drag that down. Take out the population, so I have to look at my data for 2050, which would be 357,008. So I'm going to change the population to 357,008. 114, it's getting bigger. Okay, and put it here. I have to look up my new population for 2050, the medium projection, which is right here, 403,101. So it would be 403,101, which is 129, and then I just got one more time to do it for the high projection. So I have to scroll over. So it would be 452,395. So here I just have to change that to 452,395. Oop, put that in the wrong spot. 452,395. So these would be all my calculations. So again, I just figured this out by taking my water usage times the population of that particular era times 1,000. And for 2010 back to 1975, it's a pass, so they stay the same. But in 2025, 2050, it's going to change based on my water predictions or my population predictions. So there you have it. There is phase 2, and we completed the chart for one of our countries.